Hello students, in the last part of video we have seen that metals react with non-metals and they form ionic compounds. These ionic compounds have a bond called as ionic bond. The ionic bond is formed due to complete transfer of electron from a metal to non-metal. So in today's class we are going to discuss ionic compounds and its properties. So just now we have seen how ionic compounds are formed by complete transfer of electron from metal to non-metal. Now on a general note we have to remember that group 1 and group 2 elements as well as group 16 and group 17 elements. These elements, they form ionic compounds. About this we'll be studying in detail in the chapter periodic table. Just now remember this, that group 1 and group 2, these are metals, and group 16 and group 17, these are non-metal elements, and therefore they can easily form ionic compounds in them, and bond formed by complete transfer of electron is called as ionic bond. Now this ionic bond is developed because of the charges on them. Metals, when they lose electron, they form a cation. Non-metal, when they accept electron, they form anion. Now, there are two types of ions here, cation and anion. So, both are oppositely charged and therefore a strong force of electrostatic attraction is developed in them, as cation is a positively charged and anion is a negatively charged. So a strong force of attraction is developed between them and that results to the formation of ionic bond. So this is the main reason. So now we are going to discuss various characteristic properties of ionic compounds. So before we begin the properties of ionic compounds, we must remember the reason. Strong force of electrostatic attraction, and this reason is responsible for various properties of ionic compounds. For example, the very first one, physical state. All ionic compounds, they are solids. Like let's say sodium chloride is solid, potassium chloride is solid. Okay, now why they are solid? Because of strong electrostatic force of attraction, or I can say strong ionic force of attraction. Because of this, the cations and anions are held tightly. Okay, this cation and anion, they are held tightly. And therefore, all ionic compounds exist as solids. Now remember, in your exam, this whole topic, properties of ionic compound, is important with respect to give reason question. On each and every point, a reason, give reason question can be framed. Either direct question can be asked, like why ionic compounds are solid in nature, or indirect question can be asked, why sodium chloride exists as a solid. So both ways question can be framed. You must be able to identify whether the given compound is ionic or covalent. Okay, coming back to this, ionic compounds are solids, but they are brittle in nature. That means if the pressure is applied, they can break into pieces. So let's move on to second property. In ionic compounds, cation and anion, these two are held together by strong forces. So a strong interionic attraction exists between cation and anion. So if I want to break this force, I will need high amount of energy. Melting and boiling point, we break the bond between cation and anion. So a high amount of energy is required to break this strong force. So what will be its impact on melting and boiling point? As a consequence, melting point and boiling point of ionic compounds, they are very high. Remember students, each and every characteristic can be asked as a give reason question. Now the next part, solubility, is something really interesting one. We have seen the ionic compounds. The charges exist, positive charge and negative charge. Wherever the compound contains charges, it is called as a polar compound. Here I will call it as polar solute. Now to dissolve this polar solute, I will require polar solvent. That means I will require solvent which also have positive and negative charges in them. And such solvent is water, where hydrogen and oxygen exist as H plus and OH minus ions. Therefore, I will say ionic compounds dissolve in water or any other solvent which is polar solvent. Now this phenomena where polar solute dissolves in polar solvent itself, we call it as like dissolves like. Remember this term, like dissolves like. For example, if the solute has charges on them, the solvent also must have charges. If the solute do not have charges, then it will dissolve in that solvent where there are no charges. And therefore, we say the term like dissolves like. The solvents such as kerosene, petrol, now they do not have charges on them. I will call them as non-polar solvents. And therefore ionic compounds, they are insoluble in these organic solvents. They are insoluble in non-polar solvent. Then what kind of solute will be soluble in non-polar solvent? Non-polar solute. And that's why we say like dissolves like. For example, sodium chloride. Sodium chloride exists as Na plus and Cl minus. Then it will be soluble in H2O because H2O exists as H plus and OH minus. Got it? The next property is conduction of electricity. Now before I give the explanation of this topic, I would like to ask you one question. When any substance can conduct electricity? A substance will be able to conduct electricity only when there is a movement of charged particles. So ionic compounds, are they good conductor of electricity or they are insulators? Because we know ionic compound contains charges. Now ionic compound, they contain charges, that is okay. But if they are present in solid state, will they conduct electricity? If they are present in solid state, then they becomes rigid. There is no movement of charged particles like cation and anion. Why? Because in solid the particles are tightly bounded and therefore no conduction of electricity in solid state. Remember this is an important topic. In solid state, ionic compounds do not conduct electricity. Now if these ionic compounds, if they are present in molten state, or if I dissolve in water, that is if they are present in aqueous state. Now when they are in molten or aqueous state, what happens? The charged particles, they become free to move. As soon as they are dissolved, as soon as they are melted, the cations and anions present in ionic compounds, they become free to move. As soon as the movement of charged particles starts, solution can conduct electricity, and therefore I will say ionic compound, they can conduct electricity when? Only in molten or aqueous state. This is most famous question of your board exams. Give reason question. Why ionic compound do not conduct electricity in solid state, but they do conduct electricity in molten and aqueous state? Now what happens in molten and aqueous state which makes the movement of the charged particles? It is because we are providing heat to melt the compound, or in aqueous state, as soon as we add water to them, the strong force of attraction is overcome, which do not happens in solid state. In solid state, the cation and anion remains tightly bonded due to strong force of attraction. But in molten state, we provide heat, so those forces are overcome, and therefore the charges become free to move and they are able to conduct electricity. So these were the characteristic properties of ionic compounds. The ionic compounds can be represented with certain dot structures. We call it as Lewis dot structure. One of the Lewis dot structure is a sure question in your board exam. This year board exam, 2020 board exam, had a question based on this topic. Okay, so what is done in this format? In dot structure, we represent the valence electron of the element either in the form of cross or in the form of a dot, and that's why it is called as Lewis dot and cross structure. Both are valid, but we generally prefer cross. For example, if I want to represent the dot structure of sodium, how many electrons are present in the outermost shell of sodium? What are the number of valence electron? 1. So I will put only 1 cross. Suppose I want to draw the dot structure of, let's say, aluminium. How many electrons are present in the outermost shell of aluminium? 3. So how I will represent? The electrons are represented generally in pair. So 1, 2 and 3. Now suppose I want to draw for chlorine. In the outermost shell of chlorine there are 7 electrons. So 1, 2, 3, 4, 5, 6 and 7. Instead of cross you can do dot also, but cross is the most favored one. Okay, now suppose I want to do for oxygen. What is the number of electrons in the outermost shell of oxygen? 6. And therefore we will draw 1, 2, 3, 4, 5, 6 cross around oxygen. Remember, always the cross for electrons, they are drawn in pair. And these number of dots or cross must be equal to the number of valence electron present in that element. So using this dot structure, we are going to discuss the formation of ionic compounds. I will begin with sodium chloride. Now when I have to represent the formation of ionic compound using dot structure, the very first step is I have to write the equation for formation of sodium cation. How sodium cation is formed? By loss of 1 electron. But for that I need to write the electronic configuration when it is in atomic form and when it is in ionic form. Okay. Now for chloride. Chloride will accept the electron given by sodium, will form chloride ion. So chlorine with electronic configuration 287 will complete its octet. Now this Na plus and Cl minus will be held together by strong force of electrostatic attraction that we are going to represent with the help of dot. Sodium, 1 electron is present in its outermost shell. Chlorine, there are 7 electrons in its outermost shell. So sodium, which has 1 electron, that will be donated to chlorine. What will happen? As a result, sodium will exist as sodium ion, and chlorine with its original 7 electrons will accept one more electron from sodium and now will exist as anion. So this will exist as Na plus Cl minus, or I will say now this exists as a sodium chloride. So this is how we show the formation of ionic compound using dot and dot structures. Let us discuss one more example. What is the first step? To show the formation of cation and anion. But here there are 2 sodium atoms. So I will represent for 2 sodium cations. It loses electron and form cation. Do not forget to show the charges. If you forget to show the charges, you will lose the marks. Now since there are 2 atoms, I will represent 2 atoms here. We cannot represent it in one equation. Okay, now oxygen. Oxygen electronic configuration is 2, 6 and it will accept both these electrons given by sodium and therefore will form O2 minus, completing its octet. Whatever number of electrons are lost, that is equal to positive charge developed. Whatever number of electrons are accepted, that is equal to negative charge developed. Okay, now the same we will represent with the help of cross. There are 2 sodium atoms with us, each having 1 electron in its outermost shell, as well as we have oxygen where there are 6 electrons in its outermost shell, and both these electrons, sodium from sodium, each from sodium, will be given to oxygen. As a result, now sodium will develop positive charge, but there are 2 atoms of sodium, and oxygen will have its own 6 electrons. 2 electrons accepted from sodium. As a result, it will develop minus charge, but that is equal to 2 as it is accepting 2 charges, and therefore sodium oxide is formed. Okay, we'll discuss one more example. The next example is of calcium chloride. The very first step to show the formation of cation and anion. Calcium has electronic configuration 2882 and it will lose 2 electron and therefore will have 2 positive charges on them. Just now I have told you the number of electrons lost or gained will be equal to the number of charges on that atom. Okay, now there are 2 chlorine atoms, each with electronic configuration 287. 2 electrons are lost by calcium. So 1 electron will be accepted by one chlorine and another by another chlorine atom, resulting in the formation of chloride anion, completing its octet. Now the same thing we will represent with the help of dot and cross. Calcium, it has 2 electrons in its outermost shell. Now chlorine, each chlorine has a 7 electron in its outermost shell. Remember, each and every step is important. You have to write all these steps. Now, calcium will give 1 electron to one chloride and 1 electron to another chloride, resulting in the formation of CaCl2. Calcium has developed 2 positive charge and there are 2 chlorine atoms. Chlorine atom will have its own 7 electrons and 1 electron it has accepted from calcium, and there are such 2 electrons, and therefore chlorine will develop minus charge. Okay, so therefore it will exist as a CaCl2. So this is how calcium chloride can be shown. Formation of calcium chloride can be shown with the help of dot structure. Okay, one more example of calcium oxide I have explained here. I hope the concepts are clear to you. So here we have completed the meaning of ionic compounds, how they are formed, what are their properties, and how their formation can be explained with the help of dot structures. The dot structure for complete compound can be asked, or for any particular element can be asked. So based on today's module, I am giving you some homework questions. Here there are certain questions for you based on today's video. Try to solve them. That's all for the day. Thanks for watching. Have a nice day.